Hi friends, welcome back to Team Education. Friends, in this video, we are solving problem on maximum and minimum. This topic we are chosen from functions of several variables or multivariable calculus. Okay, given problem is if the sum of three numbers is a constant, then prove that their product is maximum when they are equal. I repeat again, sum of three numbers is a constant. Okay, then prove that product is a maximum when they are equal. This is the first problem. Okay, now the second problem is here. Find three positive numbers whose sum is 100 and whose product is maximum. Here you observe friends, they are given sum is 100, product is maximum. Then find these three positive numbers. Friends, first problem and second problem both are similar problems only. Now I am going to solve the first problem. You try to solve the second problem. There is a only constant is a different. Instead of a constant, they are given 100. That's it. So remaining procedure is as it is. You try to solve the problem. If you are not getting, please ping in the comment box. Even if you are getting, okay. Now I'm going to solve this problem. First, you have to observe, friends, what they are given. If the sum of three numbers, So let us consider first three numbers, x comma y comma z be the three numbers, and their sum is x plus y plus z, which is equal to what they are saying, constant. So consider the sum of three numbers is equal to constant. Okay, this is equation number 1. Now what we have to do, prove that their product is maximum. Product means what? X, Y, Z. Now we have to prove product of these three is a maximum when they are equal. Okay friends, you consider this is the second function. Here you observe, I am considering first the function small f of x comma y comma z is equal to product of the three numbers, that is x, y, z. Okay, and given condition I am considering pi of x comma y comma z is equal to x plus y plus z minus k is equal to 0. Okay, now here you observe f is containing three variables. What are those? X, y, z. Okay, if f is containing three variables, if you want to find the maximum and minimum, we have to go for Lagrange's method. For that, we have to consider the function capital F is equal to small f of x comma y comma z plus lambda into pi of x comma y comma z. Here f is a function of three variables. So to find maximum minimum, what we require to find? Stationary points. Okay friends, stationary points. How you can get these stationary points here? Stationary points means we have to differentiate f partially with respect to independent variables. How many are there? Three variables. So fx, fy, fz find out. Equate to 0. This one also equate to 0. If you solve these three equations, then you will get the relation between x, y, z. Now, after getting the relation of x, y, z, to get x value, y value, z value, we have to substitute in a pi of x comma y comma z. If you substitute it, then you will get x value, y value, z value. Later you substitute these x value, y value, z value in the function. Then you will get either maximum or minimum. That is the procedure, friends. Okay, consider Lagrange's function capital F of x comma y comma z, which is equal to small f of x comma y comma z plus Lagrange's multiplier lambda into pi of x comma y comma z. Friends, here you observe, if you have only one condition, you will get only one Lagrange's multiplier. If you have more than one, like 2, 3, if you are there, then lambda 1, lambda 2, lambda 3, you will get respectively. Okay, based on the conditions only we are taking Lagrange's multiplier. Okay friends, now capital F of x comma y comma z is equal to, what is small f you have? X into y into z plus lambda into, what is the phi of x comma y comma z you have? X plus y plus z minus k. Okay, now consider this as equation number 3. To get the stationary values, we have to find out dou f by dou x, dou f by dou y, dou f by dou z, and equal to 0. Now I am differentiating equation 3 partially with respect to x, y, z. Okay, now dou f by dou x. F suffix x is nothing but we are differentiating f partially with respect to x. Actually, this is dou f by dou x we are denoting it. Okay. Now dou f by dou x. Here you have a x term and yz is there. Yz is a constant while differentiating partial with respect to x. Now x derivative is 1. 1 into yz is yz plus lambda into. Here x term is there. X derivative is 1 plus. Is there any x term? No. So this derivative is 0. Is there any x term? No. So this term is also, this derivative is also 0. And the constant derivative is already 0, that you know. Now, which is implies what you can say from this value is yz plus lambda, which is equal to what? 0. Yz plus lambda is equal to 0. Now, again you differentiate equation 3 partially with respect to y. Now, we are differentiating 3 with respect to y. That is dou f by dou y is equal to. Now, here you observe, is there any y term? Yes, we have a y term. Y derivative is 1. 1 into xz is xz plus lambda into. Now, x is containing. Is there any y term? No. So, this derivative is 0 plus y term is there. Y derivative is 1 plus. Is there any y term? No. So, this derivative is 0. Next, this constant derivative is also what? 0. That's it. Which is implies xz plus lambda. Xz plus lambda is equal to 0. Next, one more you have. We have to differentiate f partially with respect to z. Now, dou f by dou z, which is equal to. Now, here you have a z term. Differentiate z partially with respect to z. Okay. Then you have a z derivative is 1. Xy is a constant. Constant to 1 is a constant. Plus lambda into. Is there any z term? No. So, this derivative is 0. Plus here you have a y term. There is no z term. So, derivative 0. Plus here you have a z term. Z derivative is 1. Minus constant is there. This derivative is 0. If you simplify it, then you will have xy plus lambda is equal to 0. Friends, from this what you can say, lambda is equal to, okay, minus lambda is equal to yz. Minus lambda is equal to yz. From this equation what you can say, minus lambda is equal to xz. From this equation what you can say, minus lambda is equal to xy. So, from these three equations, what we can say? From these three equations, we can write yz is equal to xz is equal to xy is equal to minus lambda. Okay. Now, friends, what we have to do? We have to find out the stationary values. How you can get means? Okay, take any of two. Now, I am taking first two equations. What we have? Yz is equal to xz. Left side z and right side z getting cancelled. Then you will have y is equal to x. Give a box for this. Next, you take the second and third equation. Okay, third xz is equal to xy. Left side x, right side x getting cancelled. Then you will have z is equal to y. Give a box for this. From these two equations, what you can say? X is equal to y is equal to z. This is the relation we have in between x, y, z. To get the x value, y value, z value, you substitute in a which equation? Phi of x comma y comma z is equal to 0. What we have actually? We have x plus y plus z is equal to k. Sum of three numbers is what? K. So, put x is equal to x, y is also x, z is also x, which is equal to k. Now, in this case, 3x is equal to k. So, x is equal to what? K by 3. I know x is equal to k by 3. Also, I know this value is equal to y and z. Therefore, what is the stationary point you have? X, y, z is equal to k by 3 comma k by 3 comma k by 3. So, this is the stationary point. At this point, the function f of x comma y comma z. What is the function you have? Product of the three numbers, that is x, y, z. So, x is k by 3, y is k by 3, z is also k by 3. So, you will get a k cube by 27. So, at this point, it gives a maximum. He is asking in the question, it shows a maximum when these three are equal. So, is it satisfied or not? Satisfied. And what is the maximum value? K cube by 27. Is it clear, friends? Right. Similarly, you try to solve the problem. Previously, what I give, sum of three numbers is how much? 100. So, you can say x plus y plus z is equal to 100. Okay. So, you will get answer like this 100 by 3 comma 100 by 3 comma 100 by 3. Okay, friends, that is the point. So, please try to solve this problem. If you are getting answer, please comment in the YouTube comment section. Okay. Thank you, friends. Thank you for watching this video.